Hello again. Hi, everybody. Hopefully, you're starting to get the hang of this. And today we're going to start talking about the second part of section 9.4, which today is about dependent events. So we talked about independent events already, where you find the probability of one event and the probability of another event, where neither event affects the possible outcomes of the other event. And you multiply those two fractions to get your probability that those two things could happen. Okay, so today we're looking at dependent events. Let me just explain it to you a little bit and you'll get it as we go along. All right, so the formula basically is this. The probability of event A and then B is equivalent to the probability of the first event, which is A, times the probability of event B after A. Okay, so really simple example would be these colorful marbles here. Okay, so I have 12 marbles and you can picture them in a bag, and I want to know the probability that I'm going to pull out 2 red marbles. Okay, so what's the probability of pulling 2 red marbles? That means pulling one out, setting it aside, not putting it back in the bag, because that's what makes this dependent. If you put it back in the bag after you drew it out, and then these would be independent events. Okay, so you can see where they're dependent because on the second pull, we won't have the same number of marbles in the bag to draw from. Okay, so we want the probability that we are going to draw out a red and then a red. Okay, so if we write that in our formula here, it's going to be the probability of a red marble times the probability of another red after the first one and after we set it aside. So let's just kind of look here. All right, so if we reach into this bag of marbles and we pull out a red marble, okay, what chance do we have of pulling out a red marble? Well, there are 3 reds out of 12 marbles. Okay, so the chance that you're going to pull a red out of there is 3/12. So let's go here. So the first marble has a probability of being red by 3 out of 12. And I'm not going to reduce that yet. You'll see. We can do that later. Okay? All right. So once you pull that red marble out and you set it aside, we're going to just kind of cross this off. So now I know I don't have 12 marbles in the bag anymore. I have 11. So then this overall total now is 11 marbles. So when you go to pull your second marble, what's the probability that it's going to be red? Well, it's the favorable outcomes, right? So there's 2 out of 11 this time, not 12. And that's where some kids have difficulty thinking of that, okay? So the second marble, since the first one's set aside, the probability of being red is 2, because that's how many are left. That's how many red ones are left out of 11 possible marbles. And then you're just like what we did with independent events, you will still multiply these two. Some of you in the last assignment were just writing down the 2 amounts, but you have to multiply them. That's what gives you the overall probability of the 2 things happening. Okay? So you're welcome to reduce this in a couple of different ways. I could divide those both by 2, put a 1 here and a 6 here. And then 3/6 can also be reduced then to 1/2. Either way you decide to do it, even if you don't reduce it till the end of the problem, you still should end up with 1/22. So the probability you're going to pull a red marble out, set it aside, and then pull the next one out and have it be red is 1/22. All right, one more example. So let's say these are the group of students who came to math counts on a particular Wednesday. Okay, so that in math counts I have 7s above their heads and 8 above their heads, meaning 7th graders and 8th graders. So I have 4 7th graders and 4 8th graders. And I decided to put all of their names in a hat and pull out the names of 2 students who are going to be co-captains of an activity. Okay, so we want to see what's the probability that both of these names drawn, both of the people drawn, are going to be 7th graders, okay? So what we would do here is we want to find out the probability of a 7th grader times the probability of another 7th grader after the first name has been drawn. Think about it. When you're drawn or your name is picked to do a leadership role or to win a prize, and you can't win 2 prizes, your name is not put back into the drawing. That's what makes us dependent. The one event's outcome affects the other one. Okay? So let's take a look back here. I've got 4 7th graders and 4 8th graders for a total of 8 students. On the first drawing of a name, the probability that a 7th grader's name is drawn would be 4, because there are 4 7th graders, out of 8. Okay, so 4 out of 8. So we're going to put that right here, 4 over 8. And we're going to multiply that by the probability of another 7th grader being drawn as the second co-captain or co-leader. So let's first cross off the first 7th grader that was pulled out. Okay, their name was pulled. So now, if you're a 7th grader, now you have there's 3 chances out of 7. Okay, so right here you're going to have to put 3 over 7. Okay, because there were just 7 names left to choose from and 3 possibilities that they would be 7th graders. Okay, so you can reduce 4/8 to 1/2. Multiply these two amounts, 3 times 1 and 7 times 2. So the probability that 2 7th graders would be chosen to co-captain an activity is 3 out of 14. All right, I'm going to give you a little assignment in your books on dependent probability, of the probability of 2 dependent events. Give it a try. I'm hoping that this video will help explain it too, and I'll direct you into your books where you should go. And I will be back on tomorrow to kind of give you some feedback, and I also will give you some comments on Google Classroom on each of your assignments. So, good luck and have a great day.